listen to me. So lists and tuples, those are two kinds of sequences in programming. And we are going to do all of these things that are listed over here. So basically, we want to look at multiple items of data, and they should be ordered and accessible. The most famous data structures for that are lists by far. Lists are mutable, that is, you can change them. You can, for example, delete an element, delete an item on the list, or insert another item, or reorder items. And tuples, you cannot really delete an element of a tuple. You can only delete the entire tuple. But the tuples are much faster to create, for example, and that's actually one of the things that they emphasize in the tuple video. So do check out those videos. All right, so maybe I'll really quickly talk about indexing, and I will do it by example rather than just doing it by showing slides. Okay, list. We have seen lists when we talked about for loops. We just did not do anything meaningful with them, that meaningful, besides using them in for loops. So this is a list consisting of numbers 12, 13, 14. And by the way, the list elements can be diverse. For example, I could also have a string added or a boolean added to this list. And maybe we'll do it a little later. Some funny behaviors that they might not watch, mention in other videos is L times 2. Well, that is just concatenating list with itself. If it was times 3, it would concatenate the list to itself 3 times. The same way it actually worked with strings. If I have a string, some random letter combination, and I times it by a integer, positive integer, I get this string concatenated with itself so many times. Like times 2 is this thing plus itself, so you could also get that with a plus, but if you need a large number of repetitions, you can do that. There is a slight issue with working with list of empty lists or creating that, but I barely remember myself what it is. I'm not going to go into those details. We will use empty list, but we will not use empty list of empty lists, for example. Okay, so what do we need to know about lists? You can concatenate, create another list consisting, for example, of hello, and yes, I need brackets on the to open the list, and then I will just add some gibberish another, and this is a list 2, and we can consider a concatenation of these two lists. So we are we are creating a common list out of them. So different types of items can coexist on the same list. And we can look at the length of list. So length of the list L, 3, our list consisted of 3 numbers. And we need to be comfortable with indexing them. So L0, index 0, is the first element on the list. L2, in our case, will be the last element on the list. And if we try L10, we will get an error because the list was only of length 2. I will restart the There are some more interesting ways to create lists that are not covered in our class or our book, but if you look at the last suggested Socratica video, you will see things like that. So I want to have x squared for x in range 1 to 11. And take a moment and remember what kind of values this range creates. And maybe pause the video. Okay, so values from 1 to 10, including 10, not including 11. And let us look at it. Here we go. This is a table of perfect. This is a list of perfect squares of numbers from 1 to 10, including 1 and 10. So this is a little bit of a list comprehension when you give a formula and then for x in a certain range, and you can do various things with it, and you can actually get the same list using various formulas. I'm not going to say much about it, but let's move on. Now, as you have seen previously, my list is enumerated from 0, and this is by and large the case in Python and in many other programming languages. So the first index, the index of 1 is 0, the index of 4 is 1, the index of 9 is 2, and finally the index of 16 is 3. So L3, element with index 3, refers to 16. So that's something for you to get used to, and similarly, not quite similarly, but you can wonder what that is. This is the last element. The minus first is the last element on the list. Of course, we cannot start from minus 0, because that would be the same as 0. And so we can reference the list elements from the end, not just from the beginning. And sometimes, believe me, it's very convenient. Another way to reference the end of the list for any list is say that your index is length of L minus 1. And that should do the trick. So the last index is one less than the length of the list. Okay, now to talk about list slicing, we need to first try a couple of things. So let me try that. And by just looking, you can explain to yourself what it means. We start at 9 because 9 has index 2, and we go all the way to the end because we skipped the upper limit. If I was to say L 2 to 4, I would get 9 and 16. So we start at the starting point and we do not include the last index. It is the same as you had with the range function. So the upper limit is not included. So here is second and third element on the list as a separate list. So we have sliced the part of the list that we wanted to slice. We can do a little bit more, just like with the range function. We can do a little bit more and try to guess what this will do. Missing value, another column, and 2. Remember how we had ranges with 3 parameters? In this case, the upper limit is missing, so we're going all the way up from 2, from index 2 and all the way up. But we are taking only every other element because our increment or step is 2. So we started at index 2, then we picked index 4 element, index 6, and index 8. And there we stopped. So this is list comprehension for you. Fun example. L So 2 values missing, take everything from until the end, from the beginning till the end, but the increment is -1. You can guess what it does. Here we go. Reverses the order. So that is also a fun thing. By the way, we can do L reverse, and there is a difference between the two. Now, when we did this, we created a different list with opposite order to the one that we had originally. When we apply a method such as reverse, we mutate list in place, so it's still corresponding to variable L, and it has an opposite order. This one is a separate list. Okay. How do we change a value on the list? For example, I'm targeting this 81. I want, instead of 81, I want minus 10 for whatever reason, for no good reason. So I can think that this is the second element from the end. So L minus 2. Oh no, I changed my list. So maybe I'll copy this thing and I'll restart the idle. All right, I restarted the idle to avoid any confusion what the current list is, because I myself was starting to look in the wrong place. That's one downside with working with console. Okay, so now I want to change 81 to -10 for whatever reason. And here we go. L minus 2 equals to -10. So index -2 means we're counting from the end. This is minus first, this is minus second, and we have reassigned the value corresponding to the index -2 to be -10. So now we changed our list. We can concatenate lists. For example, we can say that and use augmented assignment, so plus equals to another little list with one element, hello. So this is also a way to concatenate something to the list and reassign this list. There will be another way of doing the same thing shortly. We can check whether the item is on the list. For example, whether 50 is in list. And the answer is false, it's not in the list. 49, however, is. Now, we can append elements using a method, lappend, and I'm just going to append some gibberish. I don't need brackets here, I need parentheses because append is a function, a method is a function. Method is a function of the given class. Okay, let's print the list, and here there is extra item here. Okay, so there is a function index, L, it is also a method index. I want to find the index of 9, and the index of 9 is 2. It actually gives the first occurrence of 9. If there were other occurrences, then the search doesn't even go there. It only goes until the first hit. And what else do we need? Insert, yes. Insert L dot insert, and where index I want in the second in the place with index 2, I want 1000 or 10,000 just for fun. Let's make it happen. Let's check. So now Element index 2 is 10,000. That's what I wanted. All the other elements are shifted by 1 to the right, or their index is increased by 1. So we can insert into the list if we need to. Now we can remove what we inserted or anything. We can just remove the item. That will remove the first occurrence of this item. If there was more than one occurrence. So let's check L. Here it is. We removed hello from the list, and we could remove all these elements one by one. There is a sort, which sorts the elements of the list, L sort, and there is plenty of flexibility in the sort, so we could make it work with our list, but apparently it does not want to compare strings and integers. So before we do that, we want to remove this gibberish. Remove, maybe I will do L del L minus first. So I'm removing the last element on this list, the last item on this list. Not cell, but del. Okay. Here we go. Let's see what L is. Now we removed the gibberish in the end, so sort should work fine. Sort has a lot of flexibility. If you like, you can read and kind of begin finding out how to use the key. I'm not going to do that, go into it right now. It's beyond our course. So in the slides, you can find an entire page with the most important methods. In the Socratica video, you can find out what are all possible methods, all possible public methods for changing the list. And one little note about copying the list. Let me do this slowly because I don't think they say it elsewhere. I restarted the idle, and I want to tell you that usually if you want to copy a list, you might want to think twice about it, especially if your list is long. Maybe there is another way to go around it, and there is some reluctance to allow a programmer to copy a list. So if I just say that m equals to L, then I delete L0. So I want to delete the very first element on this list, with the one with index 0. So my L is here, and my M also have the same item deleted. So this M and L, they point to exactly the same list. And that's not a way to copy lists. So if you want to create a true copy, I will do, for example, this kind of trick. So empty list plus L. So what is my L currently? Just to remind ourselves, what is my N currently? Same thing. Now, if I delete something from L, again, let's delete L0 because index is reassigned after the previous deletion. Let's see what L is, and let's see what N is. Here we go. So N is a true copy. There is actually a function method copy in the list object itself themselves. So I think you could use that as well. In any case, we want to be able to iterate through a list. We want to be able to work a little bit with two-dimensional lists, and that's where a lot of the problems are. And if you were curious and were looking around on YouTube or on any of the platforms that prepare for interview questions in sort of best companies, they use lists all the time. That is one of the widely used data data types. I'd like to finish this video with an example. This is problem 1 from our book exercises, so it's probably one of the easiest problems out there. And let's do it quickly. So design a program that asks the user to enter store sales for each day of the week. The amounts should be stored in a list. Use a loop to calculate the total sales for the week and display the result. So we could do this in one loop or in 2 loops. And we could explicitly mention the days, or we could just allow the user to enter sales as long as they want. So I decided, let me just let the user enter sales for as long as they like. While sales today is not equal to -1, so when I was doing this, I already made a choice about -1. -1 signifies the is a sentinel, so that's how we want to break the loop. Before I do that, I need to prime this variable, sales today, make it anything you want as long as it's not -1, because, well, we need to get inside the loop. I'm making it +1. And first thing inside the loop, we are going to ask the user. Actually, I'm going to copy this line instead. I'm not going to create any dot values. Let's just do this. So first time we ask outside of the loop to prime this variable. And I will need to create an empty list to store sales. So sales will be an empty list. This is one of the 2 ways to create it, by the way, just brackets with nothing in between them. And while sales today is not -1, I will say sales dot append, and in parentheses, what do I put? Sales today, the value. And then I ask for the next value. So this will populate the list with user entered data. And then we will be able to compute the total. I could compute the total right away as we are running through the list, but I'm choosing not to. And after we are done entering, I'm going to have another list. So first of all, maybe prime the variable total equals to 0. And now for num in sales, because sales is a list. And now hopefully it's not an empty list if the user was actually entering anything. Total plus equals to, what do we need to add? Num. Okay, and outside of it, we need to print num. I would say something, total, colon, and then num. All right, let's see if it works. Enter daily sales. Let me put 100, 230, and then 20. I will make this bigger, and then I'll put -1. And the total is not updating. Okay, so the total was actually the last meaningful value there. Interesting. Ah, I should print total, of course. By the way, this was a funny coincidence that allows you to see that this variable num exists outside of the for loop where it was created, and that is not the case in some of the programming languages. All right, let's repeat the exercise. 100, 230, 20 minus 1, and the sum is 350. And that's it for the video. So this was our first little program with lists.